this understanding about the various use cases, AI use cases in healthcare, here I would like to give you some information regarding how the medical imaging supports AI-enabled technology, particularly for healthcare. Okay, here are some examples I would like to highlight so that you can understand the scope of AI and particularly the medical imaging and machine learning in the healthcare, right? So this medical imaging is the technique and process of creating visual representation of interior of a body for a clinical analysis and medical intervention, as well as visual representation of function of some organs or tissues. Now look at here as an example. So all these things are done by the machines with intelligent algorithms. Now look at here. You can have different views of particular images which are taken from the human heart or a brain or any part, which can be very effectively analyzed by the doctors with the support of tools, and with that our diagnosis will be more accurate. So then, why machine learning for medical image processing? Okay, for machine learning, for medical image processing, here are some points we must remember. ML techniques help the physicians to interpret medical images using computer-aided design in a small period of time. And ML algorithms can be used for challenging tasks like segmentation with, for example, CT scan, breast cancer and mammography, segmenting brain tumors with MRI and etc. And also, with this understanding, what are the research questions we need to understand in this direction? What are the various medical imaging modalities for classifying the diseases? Because we just mentioned here, we can support the healthcare with medical imaging and also with machine learning. So with this, how can we support, right? Being a researchers and the technocrats, how can we support? So here are some research questions in this direction. What are the various medical imaging modalities for classifying the diseases? And also, what are the tools and techniques used for medical imaging? And what are the various data sets used by the several researchers in the domain of healthcare? And what are the present techniques of ML and DL used for medical imaging? And what are the considered parameters while selecting a classifier? And what are the evaluation metrics used to evaluate the classification models? Now, what we understood out of this? So definitely it has some kind of stuff for researchers. Because if you would like to take up a research in this domain, then definitely you need to understand all these questions and you need to provide answer to all these questions. And while providing answer to these questions, you are trying to understand the complete that environment or the supportive techniques and the tools to build such AI technology for healthcare through the machine learning and medical images. Now look at here. Right. So now I just wanted to show you some examples of the modalities which are used for medical imaging. The first one is the iScan 2. This is a dual iris capture scanner. It produces iris images that are compliant with ANSI some standards. Okay, so these are the devices which we use to scan the eyes, and we can find out, I think many of you might have heard about the retinopathy. Okay, I will show you some examples, the fundus images which can be observed, and accordingly we can analyze any diseases related to the eyes, and accordingly the doctors can advise the patients to go for an operation or any other kind of treatment. Another thing is called the CT scan. All of you are aware of it. Computerized tomography scan combines a series of X-ray images taken from a different angles around the human body. And another is called the MRI scan. Uses a strong magnetic field and magnetic field gradients and radio waves to generate images of organs in the body. And then mammogram, it's an X-ray examination of the breast and is used to detect and diagnose breast diseases in women. An electrocardiogram record the electrical signals from the heart to check for different heart conditions. And EEG record the electrical activity in the brain using small metal discs that's called electrodes attached to the skull. So why we need to understand all these imaging modalities? That is the question. The thing is, you can decide in which area you can work and you can contribute. Maybe you can work on eye scan too. You can work with CT scan images. You can work with MRI images or mammogram on ECG or EEG. Each of these modalities will provide you a lot of information and lot of data, and you can process using an intelligent algorithms. You can design your own algorithm by observing the limitations of the existing technologies, and by contributing so you can definitely design a better techniques, tools with the techniques, and with that we are contributing, and that is the main idea of understanding the different medical modalities or imaging modalities. So you can take any of these modalities and you can work on and you can do wonders, because there are a lot of scope to explore the machine learning and image processing concepts on these different imaging modalities. Now look at here an example of the eye scan 2, a dual iris capture scanner. So this can capture both the eyes of a patient and can immediately study whether is there any ailments or any issues with the vision, and if so, what exactly is that, whether the patient has to undergo for an operation or can be treated with normal medicine or any other things. So that's what example here, and this is what the captured image. Look at here, this is the device and this is the captured image, and this image can be analyzed, and based on that the doctors can take a decision, right? And to analyze that, we are trying to build an intelligent AI system which can effectively analyze this data and help doctors to make correct decisions without any error, or even if there is error, it is negligible. Another is MRI scanner. You might have seen this. MRI scanned image look like this, where doctors again can take a decision based on this. Now look at here, there are some marks where this indicate that there is some issues with the person, right? So that's what MRI. And similarly a CT scan, and this is the CT scan images, and the doctors can study this with the help of AI techniques and tools. Then mammogram scanner, and this is the mammography image, right, which can be analyzed for breast cancer. And ECG machine and ECG image, and you can study these peaks, how the doctors are studying it, and again you can design intelligent algorithms to study this and help doctors to make a decision. And EEG machine, and this is the EEG output. Right, now you have understood the modalities and what is the output generated by using each of these modalities, and how this data can be analyzed, and what intelligent algorithm you need to think of to analyze this. Of course, a lot of research has already been done. If at all you want to take up any of these things as a part of your future research or a career, then you need to understand the literature on any of these things and identify the research gaps and identify the scope, and then define your problem statement, and then you can work on it. So each of these modalities will help you to work on, and that's what is the idea. So with this, there's another thing called ultrasound. So with this ultrasound and color Doppler kind of techniques, even the doctors can understand what is the status of the fetus and whether it has developed properly or any issues even at the early stage. That's how the intelligent algorithms works. Okay. So with this, there is a fundus photography which I was mentioning. Right. Look at here. This is the device and this is the fundus image. And by analyzing this fundus image, you can take some decisions, and it helps the doctors to take a good decision. So taking the image of the retina of the eye with a fundus camera, fundus photography is important for diagnosing and treating various posterior segments and other ocular diseases, and the illumination and reflectance of the retina occur through the common optical path, and that is what is called the pupil, and you can study this, and accordingly the doctors can take a decision. And here are the different expertise doctors who rely on medical imaging. Now look at here, orthopedic surgeons. The orthopedic surgeons uses X-ray to assess bone breaks and spinal problems, MRI and CT scan to assess for the sprains and strains, and this is how the orthopedic doctors or the surgeons use the medical imaging and intelligent algorithms for this orthopedic issues. And neurologist uses the CT scan view and assess injuries. MRI assess all brain structures. fMRI assess brain function and response. And PET view the metabolic activity in the brain. And cranial ultrasound used on newborns and infants. And this is what is the significance for a neurologist, again a medical imaging modality. And now look at the oncologist. They use X-ray and detect cancer in both and organs. And MRI detect cancer in soft tissues and aid in staging. And CT scan differentiate masses and assesses tumors. And mammogram detect breast cancer. Ultrasound differentiate masses and guide biopsy. And these are the different modalities used by the oncologist doctors, and each of them has a potential scope for you to explore further. Then cardiologist, they use X-ray and echocardiogram, CT scan and MRI to assess the functioning of a heart, and accordingly they can take a decision. And next is the obstetrician and gynecologist. They use 2D ultrasound, verify pregnancy and assess the fetal development, and 3D ultrasound, detailed assessment of fetus, and then fetal echocardiogram, assess the fetal heart, and MRI used to verify abnormalities with mother and baby. Look at here how the doctors or the healthcare depends on these advanced technologies, right? So because many times what happens now, if the doctor could not assess properly, then they give a wrong treatment. Many times you might have observed a person has did not have any such kind of issues related to the cancer, but the doctor wrongly advised that person to go for a cancerous treatment, right? Even another very interesting thing is called anesthesia. You might have heard about it, right? Even a small change in the dosage of anesthesia will make the patient completely in a coma, and he cannot, or the person cannot recover from that coma, and the life gone, right? So even though today, right, the doctors are educated, of course, they take utmost care while treating the patient, but still there is a chance of error. That's what I already mentioned, that the doctor itself have mentioned that there is a 30% of the error while diagnosing any of these things. So definitely that makes us to think of any technology which help doctors and avoid any such kind of error. So this is what is the idea, okay? So with this, what are the tools used? Of course, you are already aware of it. I don't take much time to explain this. TensorFlow, right? You are already aware of it. NumPy, Python, MATLAB, you are aware of it, and RStudio. So these are some of the tools that you can use to do a research and come out with an intelligent algorithms. You can study your algorithms, how well it works, okay? And with all the statistics and analysis, you will be able to think of deploying solutions in real time. And now let's look at some interesting techniques used for medical image analysis. Artificial neural networks, right? Okay, how many of you are already aware of this artificial neural networks and whether you have implemented these concepts? You are already aware of it, okay? But now, one interesting observation here is, most of the times we use this ANN tools and techniques as a black box, right? We use AlexNet, MobileNet, GoogleNet, InceptionNet, and many things as such as a black box. But we don't understand how it analyzes the data, right? We apply and we find out what is the result, right? But what is how the system analyzes the data, right? Whether it has properly analyzed or not. And that's where we need to understand explainable AI. I think another expert in some other session will be explaining about how this explainable AI is used to understand the black box, how any artificial neural network or a deep learning models can analyze the data, right? And whether the data has been properly analyzed. Okay, so that is what is called explainable AI. Okay, so that is what the transparency in data analysis. Okay, many times the doctor will simply suggest you take this medicine and all. Don't you think that you have some confusions there? Then what is expected? The doctor has to interact with the patient. Why you have to take this medicine? What is the main reason for this ailment? right? And everything needs to be properly discussed with the patient so that the patient will have some kind of faith in the doctor. Otherwise, if simply the doctor suggests that you take this medicine and do these exercises, then obviously, right, the patient may not be happy with that kind of prescription as such. So very similarly here also, we can apply many deep learning architectures or any advanced technologies to analyze the data and also to take a decision, but still we need to understand that how the decision has been taken, what process has been done, and that's what is called explainable AI. There is another domain, right? So even you can explore many things in that. So this is an example of artificial neural network which mimics the human intelligence, and this is what is called the core idea which has been used to build a modern AI technologies. So these are called the input neurons, these are called the output neurons, and these are the hidden layers. As you are already aware that our brain is equipped with billions of neurons, and each neuron is responsible for processing a particular piece of data, right? See here, standing here looking each one of you, I can understand each one of the faces, right? At the same time, I can take certain decisions. So how this is possible, right? Okay, the segmentation, analysis, audio data, video data, image data, everything is assimilated, and the billions of neurons which are equipped in our brain are responsible for processing each piece of data and finally enable us to make a decision in a real time. And the best example is driving. That's what I already mentioned. Whenever you are driving, you should have a lot of things, right? Automatically your hand will move on to the gear. Automatically your leg will go to brake and an accelerator, right? Clutch. And your vision will be with the road, whether any vehicles are passing, right? So you have to observe a lot of things, how all these things are done, how it is processed, how the decisions are taken in real time. And that is what is the natural intelligence. And this is artificial neural network is the building blocks of any modern AI technology and the tools, right? So this is the input, this is the output is expected, and in between there are multiples of neurons and a lot of weights and a lot of processing will happen, and finally it establishes a non-linear relationship between the input and an output, and finally enables the AI tool to take a decision. And this is what the technology, of course all of you are aware of it. And then convolutional neural network, CNN architecture, right? So kernel, input image, feature maps, pull feature maps, etc. I think you can understand the complete architecture of a convolutional neural network, how various convolution operations are done at various levels, and finally how we arrive at a decision making, right? So that's very interesting technology. But here we need to understand how each of these stages have been accomplished, right? But many times we don't analyze that, right? But true researchers, or if at all you want to contribute something, right, then we have to analyze each of these steps, understand, and accordingly we can identify the limitations of the existing architecture, and we can put our idea and knowledge in building a better system. So a convolutional neural network is a category of machine learning model, namely a type of deep learning algorithm well suited for analyzing the visual data, and CNNs use principles from linear algebra, particularly convolution operations, to extract the features and identify patterns with images. That's how you normally do several iterations, several epochs. I think you might have already heard of epochs. And you train the model with millions of records, millions of images. For example, I want to deploy in real time face recognition system for example a class, right? How I can do it? So let us assume that a camera can focus on each of the persons, get the picture, and the model has already been trained. It checks for a database, a reference database, and compares the face with the reference database and identify that yes, this face matches with this face, and accordingly it marks the attendance. And that has to happen within a minute or within a fraction of a second. How it can be done? And what are the challenges there? Right? So we need to always understand the deployable models. right? Research is not just we are designing an algorithm, but also we should understand the feasibility of deploying that solution in real time, right? Okay, and what are the challenges in real environment? For example, today at the time of training the model, the person comes with a spectacle, right? A neat shaved face, but in real time or during testing, the person comes without spectacle, wearing a hat and with mistake or a beard. How can a system recognizes that? But we human beings will recognize that. But we need to provide such an ability to the machine as well. Then how the training should be done? It is not that we can pick the samples and we can train without proper reason or understanding. Okay, you should always train any deep learning model with varieties of data, not with the same data, right? For example, if a person puts 100 signatures, if those 100 signatures are done consistently, there is no significant changes in the signature, then only one signature is enough to train the model. Not all 100 signatures, right? But if there are some variations in the signature, study those variations and identify those variations and train only those signatures for training. And that's where you can understand the importance of clustering. I think all of you have heard about what is meant by clustering. Clustering means grouping similar objects or similar data. Here, as an example of a face or a signature, I collect 100 signatures from each person, but I cluster it, and those 100 signatures clustered into, say for example, 10 groups, and that indicate that all those signatures which are clustered are more similar, and instead of training my deep learning model with 100 signatures, I can train with only 10 signatures. Because only those 10 signatures have significant variations. The same thing is applicable in any training, right? And that's where we have to think of training the models more efficiently with the limited resources, right? I think you might have already heard about the concept of cloud computing and edge computing. Edge computing means I have a mobile and I have all the processing elements and the software equipped in my mobile, and my mobile is responsible to make a decision, right? But in a cloud computing, I have to send the data to the cloud, let the cloud process the data and give you the decision. Then a lot of issues are there. The confidentiality of your data, the privacy of your data, and the protection, security of your data. Everything matters. And also the resource matters, the time, real time matters. So now the people or the technocrats are thinking of coming out with a edge-based technology. Edge-based means your mobile is equipped with all the required tools and processing power, and it can process and enable you to make a decision at your place only. That's what is called edge computing. So in future generations of the technology, even the technocrats and the researchers are concentrating on the edge computing technology, right? So that's where we can understand all these ideas. Okay, so with this, there's another thing called the transfer learning. I think some of you have explored this transfer learning. Okay, you can train the model with some data, get those weights and use those weights to train your model so that you can reduce the significant amount of training time. And once you understood that, yes, it can perform better, then you can study the for your data and for your applications, and then you can think of deploying it, and that is what is called the transfer learning. So you have a model and you get a knowledge, and then source task domain and then target task domain, that's a model. I mean to say, because we are all very comfortable and we are very good at a particular language like Kannada or in English, I don't think it is a very challenging or difficult task for you to learn Hindi or Tamil or Malayalam in another few months, because you already understand a solid idea about what is a language, what is a grammar, what is the construct, what is the meaning and all. With all that knowledge, you can easily learn any other language, provided if you concentrate and if you have an interest and a passion. So the same idea is also used in a transfer learning. Okay, you can use a pre-trained model which has been trained on some data set, use those weights, and you can use that idea, and again you can train your model or data set for your data set, and you can use that knowledge for predicting. So that's what is called a transfer learning. And another thing is called the random forest, where we have multiple decision trees to make a decision. That's ensemble techniques, right? All those things are called the random forest. These are some of the techniques we can explore for building an intelligent AI models. Another is called support vector machine for a classification purpose, right? Okay, optimized, large margin classifiers, support vector machines. Of course, you might have already studied about the core mathematical concept behind what are support vectors and how it does all those things. So with this, in another few minutes, I just cover up other very interesting findings of the literature so that it may be very useful for you to plan your future work if you have already completed your research, or you can even think of defining your research problem if at all you want to work further. Some of the key tasks involved in medical image processing image acquisition, as we already mentioned, the different devices and modalities. So depending upon your interest and the passion, you can think of using any of these modalities and you can acquire the image and you can work on ultrasound, MRI, CT scan and X-ray machine. And here are the pre-processing. What is pre-processing and why is pre-processing is required? Now look at here. Original MRI after skull stripping, and this is what is of interest for the doctors to make, analyze and make a decision. And this is the original medical